Okay, it's November 10th, 2014, here at the Computer History Museum. I'm Steve Diamond, and we're doing an oral history of Bill Mensch. Thanks, Bill, for joining us.
Well,
we'll be talking about a variety of subjects and your perceptions of what's happened in the past and perhaps where things are going in the future. Why don't we start out by talking about your youth and your education, and then we'll follow that up into your transition into the semiconductor world.
All right. Well, thanks for inviting me. It's an honor to be here right now. And I will enjoy telling you what I know about my life, how I got here, and we'll start then with my growing up on a farm in Pennsylvania, Bucks County, about 35 miles north of Philadelphia. Very rural. The dairy farm had like 26 head of cattle, and I was a middle child of 8 children I grew up with, and as a result I got to explore because it was more fun being outside of the house rather than inside the house. When I was probably about 10 years old, we may have gotten a TV. We had a radio, liked to listen to the Lone Ranger. As soon as the cow's milking was done for the evening, we'd run in and try to get a good spot in front of this tall radio. And so I started out what you would call, I call, pleasant poverty. So the dairy farm, to support 8 children, that's the source of income, 26 cattle. So my father was a small businessman, and the farm was his business. He was given that farm by his father. And so there's a lot of history associated with that happening. I found out later in life that my father wanted to be an engineer and wanted to go to Drexel. He wanted to be an electrical engineer. So when you look at my past, I don't think there's many indications that I'd be sitting here talking to you. I don't know what actually was the path and what the guideposts were, because it was like I was following something, but I didn't know what it was.
When is the first time you thought of yourself as possibly an engineer?
It was probably when I was an engineer. In other words, the reason why I went to college was because I took the academic classes in my high school, and I really didn't know even what that meant. So therefore, I took the classes that I was interested in, I suppose, math and science. But for me I never thought I was going to be an engineer. I thought I was going to be a laborer, because that's what you do on a farm. So you learn how to do things that you're told to do. We need this project done. We need to plow that field. We need to cut the hay. We need to bale the hay. We need to bring it into the farm. We need to milk the cows in the morning, in the evening. And all these things you were doing and you were expected to do. So hard work was what I knew, and I enjoyed that. I enjoyed being outdoors. So for me to think that I was going to be in an office environment, that's nothing I ever thought I would do. So maybe when I was 18 and the guidance counselor said, well, you've prepared yourself to go to college, I'm thinking, this is a mistake, because I wanted to get out of class. I didn't like English, didn't like history, didn't like social studies. I just liked math and science. And because you could get real answers. If somebody asked me, what did this poem mean? I'd go, why don't you ask the poet? I mean, really. I mean, what did I get from it? That wasn't what I remembered the question to be. So to me, going to college was not expected. None of my family ever went to college.
So you found yourself studying engineering.
Yes, and I think I studied engineering because my dad had engineering magazines, maybe IEEE magazine. Well, I don't know if IEEE was around, maybe. But
oh, it was.
It was around, but some of these magazines like Spectrum started 50 years ago, and this was, well, maybe that was something. But what I'm getting at here is he had some electronic magazines, and also he equipped the farm with a generator that when the Philadelphia Electric Company power went out, we need to keep the milk cold. So then he had a big circuit breaker from a ship, I think, and he installed that, and then started the tractor and started the generator, so to keep the milk cold. So that's electronics. So I suppose I got that from my dad.
Do you remember what classes interested you most?
In college?
In electronics, in engineering?
No, well, Temple was engineering technology, so it's more like learning how to use equipment, technology, not the theory and the physics. And so, therefore, the classes that I took were just to get my degree, get out, get a job as a technician, thinking I'd be able to make more money as a technician than as a laborer. So I was rudely awakened when I'm working for Hinkles and McCoy and making about $150 a week with overtime, and then working for $85 a week. It didn't make sense after I got my degree. So I needed to make some changes, and I decided to be an engineer to pay my mom back.
So what was your first job after college?
Okay, I worked for, and I very seldom tell people this, but for 3 months I worked for a company called Polyphase in Bridgeport, which is across the the Schuylkill River from Norristown. And it was an old manufacturing community, and it was in an old factory that this Polyphase was. It was a depressing situation for me. That I didn't start until it would have been in the spring of 1967. And I first went into the Army for National Guard training, and that's why I did an interview right out of college. So it was after that that I got a recommendation from a friend of mine that found a job there, and he got $100 because I took the job. So then I decided this wasn't for me. So I quit without another job. Then I worked for Philco Ford, and that's where I was introduced to semiconductors.
So tell us about that.
Well, at Philco Ford, now Ford bought Philco, and I think it was for the electronics that go into automobiles. And then Ford, or I don't know if it was Ford or Philco, acquired GME, which was the first MOS manufacturer of semiconductor products. And in fact, they had a 1024-bit ROM back in the probably 67, something like that, because there was a jet engine controller that was built out of these with 8 1024-bit ROMs. And then of course there would have been memory in there, RAM in there. So that is where I learned about semiconductors. And then I studied the physical characteristics of semiconductors. For instance, you want to know the f-tau of an amplifier and the frequency, and then the thermal coefficients of materials. So if you put a semiconductor, a regulator, solid state regulator, on a heat sink, what's the thermal coefficient from the surface of the semiconductor to the actual heat sink? And so these kind of basic characteristics of semiconductors is what I worked on as a technician. So then I was interested in their characteristics. I went to Villanova night school, took 4 different engineering classes to see if I could be an engineer, and then I did well in those 4 courses. Then I wanted to transfer my credits from Temple. I had like 109 credits from Temple. You need about 130, 135 to be an engineer, thinking I could finish in 1 or 2 years. They didn't accept my credits. That's when I came to Arizona, because I had a fraternity brother that came to Arizona, and he went to ASU and I went to the U of A, interestingly enough. I never saw him again. But that's how I got into semiconductors, is through Philco Ford.
And how did you get from there to Motorola?
Well, good question. At Philco Ford, being in the radio business, television business, excuse me, Motorola was a leader in those circuits. So Philco Ford was trying to figure out, or Philco was trying to figure out, how Motorola was developing some of their high voltage circuits. So the breakdown voltages and other things, the characteristics of the circuitries in TVs and radios is what Philco was looking at. So then I knew who was the leader because we wouldn't be trying to figure out what the follower was doing. We're trying to figure out what the leader's doing. So I knew then Motorola was the leader. So I wanted to work for a leader. And so my whole goal was set on working for Motorola after I got my engineering degree.
So how did that happen?
Well, that's another interesting question. It was kind of bizarre, actually. In my senior year, so it took me 2 years to get my engineering degree at the University of Arizona. Very good school back in those days. The professors were writing the textbooks. And actually, I took a course, and it could have been one of his first courses or an early course, because University of Arizona professor started systems engineering. I didn't know that until recently. But I took a course from him, and I did very well in that course. So what happens is when you have businesses coming to interview the students, it was clearly stated that if you're not graduating, if you're graduating in the spring, you interview in the spring. So if you graduate in the fall, you interview in the fall. Well, for whatever reason, I really wanted to get interviewed at Motorola, so I went to the fall interviews and found that there was nobody signed up, and Motorola was looking for someone with over a 3.3 grade point average. And so I'm thinking, hey, there's nobody signed up. I'll sign up because I have a 3.3 grade point average. So the head of college recruiting came. His name was Jerry Fulton. And Jerry interviewed me, and we had a wonderful conversation. And as it turned out, Jack Hennishin was a manager from Philco that went to, no, I'm sorry, it wasn't Jack Hennishin, it was another name right now. I can't think of his name. He was at Philco Ford. He was like 2 levels above my boss at Philco Ford. He was at Motorola, so I had something in common. There was somebody I knew. Oh, I almost had his name. So what happened was, I'm talking to Jerry Fulton, and Jerry and I get along really good. He says, we got a job for you, partner, because I had 2 years experience, and so I had this engineering technology background and an engineering degree, so they were looking for people with experience like that. So when the spring semester came, I didn't do very well in that interview, and I found out later why, but I don't need to get into that right now. It just didn't work, and I left in the middle of the interview thinking, I already talked to the boss. And so that spring, when you get your responses back, I got an employment offer from Martin Marietta in Denver. I promptly put it back in the mail. Thanks, but no thanks. Got one from NCR in California, working for a computer company. Both of them were computer. I promptly put that in the mail, thanks but no thanks, waiting for the Motorola. Motorola gets the letter, signed by Jerry Fulton, said thanks for interviewing, but sorry, we don't have a position for you. I wanted to jump in the mailbox to get back those other letters. Mm-hmm. So instead, I called Jerry and said, hey, Jerry, this is Bill at the University of Arizona. He goes, right? I said, well, I got this turn down letter, and I thought you wanted to hire me. Oh, Bill, there's a mistake. Throw that away. I said, Jerry, you signed it. He said, that's a mistake. Throw it away. There's another letter coming. That's how I got the job.
So what was the job that you were hired to do at Motorola?
Well, what Motorola
presumably what interested them when they interviewed you.
Well, you know, Motorola is an awesome company. Was an awesome company. It's kind of fractured right now. But Motorola had a training program, and you spent 3 months in 4 different areas of the company. On that training program, you were treated like royalty. Everybody wanted a trainee working for them. The reason why is the training department paid your salary, so your free labor for the department that you're working for. So I thought about it, and I thought, well, why don't I learn Motorola? So my first 3 months, they called them rotations, whereas in the applications department, part of marketing. So I worked on the modem, 6860 modem, working with a consultant. I think his name was either Anderson or Jacobson. There was Anderson Jacobson was the name of the modem manufacturer at the time. Well, they wanted to do an integrated circuit modem, low speed, 300 baud. And so I got to flow chart that and look at some of the circuits that were needed to make the modem what it needed to be. So then the next 3 months I spent in the design group designing what I specified in the first one. Then I wanted to get into MOS processing because I wanted MOS because I knew MOS was the future.
And how did you know that?
Again, it was about some basic characteristics that I learned at the University of Arizona and saw at Philco Ford, that the bipolar process was slower switching if you go to the highest performing circuits were going to be voltage controlled, which is the FET. And so therefore the analog or the bipolar was current controlled, so it's slower. But at the time it was the fastest, but you knew in the future it was going to switch from bipolar to MOS, field effect transistors. So what happens is I know that I want to be in MOS. I knew that was the future. I was working for a leader in the business. I wanted to be in process design next. So then I would manufacture what I designed, so to speak. Not really, but that's the idea. And so that wasn't available to me. There wasn't a MOS spot available as a trainee. So I worked for a bipolar part of the Motorola that was doing emitter coupled logic, which was the fastest switching circuits in the world at the time. And so that ECL, Motorola called them MECL, Motorola ECL. And so I designed a triple diffused, we called it MECL-N, which was the end of the line, so to speak. And that was, I was diffusing into a bulk background, the collector, then next was the base, and then the emitter. And that was really hard to do. Nobody had done it before. So I decided I'm going to create a program model so I could change the times and temperatures, and then I would be able to see the diffusion of the ions into the background and into the collector by the base, and then the emitter into the base. So if you punch through the emitter through the base, you've got a diode, or you got a short really, because they're the same type of material. So that's what I did. And so then I could get all the design characteristics with 5 different programs that I wrote. And there was a guy named Jim Dunkley that had a cookbook for bipolar processing. So what I did was automated his cookbook. So when I got the next rotation was marketing. So then I wanted to see how you sell these things. And so I worked on data sheets. And then there was a quote needed for IBM for various size memories and various volumes of memories. So it's a learning curve over like a 7-year period, like 7 different, all I remember is 777, like 7 different volumes, 7 different years, and 7 different densities. And so it was like 7 pages of numbers. So I didn't think the secretary would type up the numbers very accurately, so I decided I would write a 4K program, and all I did, it was a spreadsheet without, so you plug in the numbers and you print it out. It was a Fortran program on a Silent 700, which was a terminal at the time, and then I copied on a regular yeah. So then it was, I copied it on a regular paper, so because that rolled thermal paper wasn't fun to handle. So then I did that within a couple of days, and then on to the next project. But marketing is how I was forced by the marketing people into the logic group because there wasn't an opening for me in the microprocessor group, which I wanted to be in. Well,
so why did you want to be in the microprocessor group? You got to Motorola, you worked on designing the modem chip, you worked on the processing from the bipolar chips. How did you decide that microprocessors were where you wanted to be?
It wasn't really microprocessors at the time. I was focusing on the fact that I loved the design characteristics of MOS. But as it turns out, I got 4 offers. In every department that I worked in, they gave me an offer. The 5th one actually, I'm sorry, would have got 5 offers. The 5th one came from the high voltage bipolar organization that had the TV circuits. They wanted me because I could model the junctions, and so we could figure out what the breakdown voltages were, which was a very important characteristic. The reason why I didn't take the job is because when I was told by jury, hey, Bill, you need to get off an extra month on this, and you need to pick. And so I needed to pick. Well, I wanted to work for the bipolar group. I sent them a letter, never got a response. This was when you have inter-office memos sent around. We didn't have email. And so what happens is I never got a response. And so then the marketing group, the MOS marketing group, said, we haven't really gotten circuits to work out of that MOS logic group, so we want you to work there. So they're the ones that said, you need to take Bill. Well, meanwhile, I never got a response from the bipolar group. So then after I'm working for a week, I get this call from the head of the bipolar group that wanted me to work there. He says, Bill, where are you? I said, I'm in the logic group. Oh, he says, well, we want you to work here. We told you that. I said, yeah, but you didn't respond to my memo, and I thought because you didn't respond, you didn't want me. So that's why I'm in the logic group. Now I made a commitment, I'm here. He said, Bill, did you see the TV last week or the week before when that tornado set down in North Scottsdale? I go, well, maybe. He says, that was my house. I was putting my house back together. That's why I didn't respond to you. And I'm thinking, a tornado changed my path.
So what did you do?
I worked in the logic group, and then what I did there was something that, another one of these opportunities. There was, nobody wanted to design just logic gates. Motorola had a local logic, I called it loco logic, in Boston for some of the computer companies. And so you could design your own custom circuit with standard cell library. So it was my job that I took over from somebody else that probably didn't really want to do it because it wasn't that much fun. But you had to put in the capacitances on the inputs and the outputs. You have to have the drive capability and the performance. It was if you remember the old logic libraries that had their various characteristics that you had to have in a sheet that described the performance of the various logic gates. So I designed the local logic library for PMOS metal gate, PMOS silicon gate, CMOS metal gate, CMOS silicon gate, NMOS metal gate, NMOS silicon gate. So I learned all the processes. So it was kind of like, wow, now I know how it all works. So then, because I did that, then they wanted me to design the process control monitor that monitored all of the wafers for the memory products and for the microprocessor products that ran on the NMOS enhancement load process that we designed our chips on. So then I designed the process control monitor that was stepped into the wafer in like 5 different locations. Then you probe that to get to know whether the process was in spec or not. So then I designed that. Then I was asked to join the microprocessor design group, and that's why I worked on that. But then all the engineers were working on that, and then they needed somebody to do the peripheral interface adapter. So I was pulled off the microprocessor to design the peripheral interface adapter, which connected the microprocessing element, the memory elements, to the real world, driving solenoids, driving just external switch or reading external switches. And the PIA was used also for a keyboard interface, so that you could drive with some of the pins you drive the rows, and then you sense which key is to press. So I got a wonderful introduction to the whole system by doing that peripheral interface adapter.
So on the PIA, what what did you do? How did that project start, and what were your contributions to it? And take us through the...
Okay, so at Motorola, they had that applications department. They specify things. So marketing specified what they thought the industry wanted. And so as a result then, you would take that spec that was created in combination with the design group, but mostly dominated by the marketing group. So in some cases that's a good thing, some cases a bad thing. The 6800 microprocessor was thrown together by a lot of contributors, so therefore the design group didn't really have much to say about what went into it. And if a sales guy came back and said, hey, we need this instruction, so they added another instruction, whatever. So it was kind of a random thing, but it was built on the specification of the PDP-8, the 6800. The 6502 came later, was the PDP-11, better architecture. And now going back to my contribution on the PIA, somebody picked the numbers. I didn't pick the numbers. They said it was supposed to be 135 mils by 135 mils. So that was my challenge. So then I think...
And what was the feature size?
It was 0.8 micron, 800 nanometers. So it was 0.8 micron. That means 4/10 of a micron. I mean, 0.4 mils. 0.4 mil. I got the number system right. The line width, metal line width was 0.4. The spacing was 0.4. So it was 0.8 mil centers. So that was large compared to the future where we are now. So we knew what those characteristics are, and so how they came up with 135 by 135, I don't know.
Maybe that was the cavity or something.
I think sales said we needed that to make money. And so, no, it wasn't the cavity, because the same package accepted to 217 by 210 mil 6800.
So you got the outline of the die, the size of the die.
Size of the die.
And what did they tell you?
Basically,
did they give you a pinout?
I don't know if I was given a pinout or I chose the pinout right now. But when you design a chip, you know on one side is the data bus because you're going to latch in information from the microprocessor. Then you're going to have I/O, so across the chip you have a data path. That data path kind of tells you where you want to put things. So I don't know if I actually defined the pinout. I could have, because I knew I wanted the flexibility to define where things were. Actually, maybe I did do the pinout because I got a patent on it. It was the first patent for the layout of an IC. And other lawyers have called me from time to time, not recently, but they say, how'd you get that patent? Well, my patent lawyer, Charlie Hoffman, he put that together, but he thought it was worthy of a patent, and so I got a patent. The patent is that I placed things that if you changed it, it would be a bigger chip. I convinced the patent office that it was unique, and if anybody copied it, they were violating our patent. So, you know, a patent was created, patent office was created in 1800. Well, 1800 is when Thomas Jefferson was president. He was the first head of the patent office. And I do have a patent. The very first patent is on potash. But in my office, Charlie gave me that, copy, but he made it look real. So going back to that is what a patent is about. It's about teaching someone what you know and what you've invented. So you get the monopoly, that's the word that's on the patent. You get a monopoly if you're willing to teach someone. So I was teaching them how to do a peripheral interface adapter, so I got a patent on it. So that device, I chose every transistor on there. I taught the mask designer how to design integrated circuits. And when he said he couldn't do this one part, I stayed up after a party. I stayed up on a Friday night and finished the chip. And so, but he didn't have the advantage of knowing what he could do with the actual transistors and the resistors and to make it work. So I figured it out. And I took it in on Monday and say, I think we're done with the chip, now we just need to check it.
So what tools did you use to design this?
Okay, so Back in those days, there was no LVS, no layout versus schematic. So you had to check those things. And it was with Rubylith, so you actually had a flatbed with a knife on it and cut it out, and then somebody had to peel off the Rubylith from the places where you want a light to shine through. So those patterns were driven by a Calma, it was the original Calma 1 system, could drive a plotter, or it could drive a Rubylith cutter on a flatbed. So the simulation of it, I was one that liked computers. So I was given by a friend of my aunt back when I was at Temple. He was an IBM supervisor, and when my father had passed away, and so my aunt said, maybe this friend of mine, George Rogers was his name, maybe he knows what you could do after you graduate from Temple. And his one comment that, I don't remember anything else, I don't even remember a hello or goodbye or anything, get into computers. So that's why every chance I got, I used a computer, because I had one piece of advice, get into computers. So that's what I did. So that means that when I'm designing an integrated circuit, I want to use simulation because I knew the computer could help me figure out whether it was going to work or not. So I had to prove out that the PC control, or the process control monitor matched up with the actual characteristics in the simulation program. So I knew whether that was accurate or not. We had to make some changes to the model because of things I found. And I found that narrow transistors had a higher voltage threshold than a short one. And these are things that the memory product guys didn't use. And so they had to change their design because of what I found on the process control monitor. I put very narrow transistors, very wide transistors, very large transistors, and very short transistors. So I knew the characteristics and what the actual sizing might have an effect on. So I did that, and then I matched it up. So then I simulated everything. So I simulated everything. I knew it was going to work.
What software did you use to do this simulation?
Motorola, there was an engineer there. His name was Frank Jenkins. He, I think, graduated from Stanford, but I'm not sure if it's Stanford or Berkeley, one of those two. And so Frank wrote a program called TIME, T-I-M-E. Stood for transient something, integrated, whatever, microelectronics or something like that, circuit analysis. So when he went to Motorola from Stanford or Berkeley, he wrote M-Time, so he just put the M in front of it. And so that M-Time, Frank and I became friends. I was taking the data in the lab, he was writing the software, then I tell him when the model had to change. We only had like less than 10 characteristics that we plugged into that model. It was very empirical. So I got to know everything about the transistors, and what worked, what didn't work.
How complex was this chip? How many transistors or
PIA?
gates was in that?
I'd say 1,000 to 1,500, not that many. We still supply it, by the way. We're still getting orders for a compatible version with the original design.
And how many I/O lines did it have?
Okay, it had 20 I/O lines. It had 8 individually programmable bits, ports, on one write. So when you write with an 8-bit processor, you store your accumulator into a register. We had bidirectional control. So we had a data direction register and a data register, and that's Intel, I don't think, ever had that. So we actually were selling PIAs with 8080 processors from Intel, because they had 8 bits out and 8 bits in, but not individually selectable. So that really benefits if you only have a couple of bits, but you have more outputs or inputs or whatever. So you can mix and match. NCR bought, I don't know, they were a big purchaser of PIAs. Motorola would force them to buy a 6800. They were buying Intel processors, but buying my PIAs. So Intel marketing thought, hey, for every 10 PIAs, you got to buy 1 microprocessor. So I don't know what they did with the 6800s, but I think they tried to find a home for them, sell them or something. But they used my PIA with the Intel processor. So the other two, so there's 2 handshake pins on a port. So the handshake on 2 different ports. So now we have 2 8-bit ports. That would be 16 pins. than 2 handshake pins per port. So when you wrote to the output, let's say, when you wrote to the output, you wanted to tell the rest of the world, I wrote to the output buffer. Now it's your turn to take it, so it's handshaking. And so then when that peripheral took the value of the pins, it would tell you that it read the pin, so then you can go back and forth. It's interrupt driven or polling. You could see that this transfer had occurred. So that's basically a PIA. The other side of it is the interface to the microprocessor. 8 data pins and register addressing, and then you have read write and phase 2 and power supply. That's the 40-pin part.
What other chips did you do at Motorola?
Well, my patents, I designed the buffers that were used on all of the parts. So,
I/O buffers.
I/O buffers. They're, clock generators. I designed all the clock generators, and so the individual circuits. Because of my work with the standard cell library, I knew how to pick the transistor sizing. Because you look at the loading that you're going to have on a data path or a wire, you know what you can calculate the capacitive loading. If there's a resistance in it, you could put that in the model, simulating it. So all of that I knew, and that's what so all of the chips at Motorola used some of my circuits.
So you were kind of the analog guy in the digital group. You understood the dynamic issues with the cells.
Yeah. In fact, that later, much later, after I started my company, to survive, I taught Xerox how to design microprocessors, and that was a big part of what they were missing. They didn't know how to really get a microprocessor together. I showed them how to do that, because you have to use some basic physics. You just what capacitive loading do you have on it, and if you don't know what the capacitive loading is, you don't know what transistor sizes will be required to switch in a certain time frame. So yeah, I knew the characteristics of the transistors.
So after the PIA, what did you do next?
Well, my next chip was to design a programmable timer unit. But it was in the middle of that Chuck came a-calling and said, Bill, do you really want to go to Austin, Texas? No, I don't really want to go to Texas. So he says, hey, how about if we get a group together and we design the microprocessor we really want to do, and you know that the 6800 isn't the right one. It's too big. Right, Chuck, I know it's too big. So Chuck said, who do we need to be successful? Who can we take out of Motorola to be successful? I'm going to look for some place that we can land, and we'll design the microprocessor. And that's what started my thinking. Motorola isn't going to be the place I'm going to retire at. But another thing happened. At Motorola, I made a bet with the operations manager of the MOS group, Otis Wilkins. Otis ended up at GTE heading up their semiconductor operations later, but Otis said, was it Otis? Maybe I have the wrong guy. But anyhow, we had a party for releasing the microprocessor and the PIA at the same time. And so to manufacturing, get the samples first. And so what I said, I'll bet, now this is after a glass of wine or 2 or 3, at a favorite restaurant, everybody's celebrating. I'm saying, my chip will work the first time. And he says, that's an easy bet. No chip has ever worked the first time. So what's the bet? I said, how about dinner? What do you think? You and your wife, me and my wife. Dinner. He said, okay. Where? I said, well, for me, the Wharf in San Francisco. We're in Phoenix. He says, well, I know a restaurant in Scottsdale with a $100 bottle of wine. I go, okay, you're on. My chip came out, worked. Well, why did it work? We didn't have LVS. What I did was I checked it 5 times. You make a bet, you better back it up. I wasn't wanting to buy him a $100 bottle of wine anyway. Well, he never paid off. So when somebody doesn't pay off, then you go, is this the right place for me? And then another thing was said to me in a meeting with AMI, which was our second source. They said, if Bill's chip works the first time, we're going to give him the first engineering bonus. Whoa. And John Buchanan, he's passed away now. John, like, what? What about me? He was the guy that was in charge of the project leader of the 6800 in this meeting. So he wasn't happy with that because he thought probably that he deserves a bonus just because he held the team together to get the project done. Chip came out, worked the first time. Never paid off on the bonus.
So at that point, you were skeptical about how successful the 6800 was going to be?
No, I thought that would be successful. No, it was the fact that I needed to leave because not one, but two promises were broken. That was powerful.
Okay.
So who do you think I meet in the hall at 52nd Street? Jerry Fulton. Bill, I heard you're leaving. I said, yeah, Jerry. I've got to go.
So then what happened?
Went to MOS Technology. So now I'm fueled by, we need to make this successful.
So what was MOS Technology like when you showed up?
Oh my gosh.
What were they doing?
That's a good question. It was run by calculator people out of Texas Instruments. And so the operations guy, I forget what his name was, but he was a very successful Texas Instruments production manager. So he was like vice president of production. And the people that were designing the calculator chips, they were PMOS metal gate. That's what I think TI had at the time. And so they were very successful in the calculator business. And in fact, I almost had his name. His first name was Don. But he came up with a thing called spot knocking the masks. So they had perfect masks when nobody else had perfect masks. So they had a great manufacturing team from a TI background and had a great logic team designing calculators that were really significant. They're scientific and everything. So they knew what they were doing. So Don McLaughlin was the vice president of engineering. He was one of the founders. So what happened when we got there, they didn't want us there. They were saying, well, how could John Pavin, the founding president, how could he hire this group out of the West? They don't know what they're doing. And we know what we can do. Why aren't we doing it? So they weren't happy that John Pavin brought in a team to do a microprocessor. Now the actual 65, where'd that come from? I guess it's lower number than 68. I don't know where the 65 came from. And then of course, you start at 00, and then 01, 02, like that, but 00 isn't too interesting, so the first microprocessor is 6501.
And how big was the team that came over with you?
8 of us. And then we hired one. I think we hired one back there. So we had 2 mass designers. We hired 1 mass designer, so we had 3 mass designers on the project. Harry Bauckham and Mike Janes, Janes, I think. And then Terry Holt was the operations guy. And then we had Chuck Peddle was the marketing, and he was the ringleader. He was the business guy. He was the guy that said, if we do this, we can create a good business opportunity. So Chuck was the marketing guy, and he kind of controlled the opportunity, so to speak. He put together the package for MOS to the contract. And so then there's myself, Ray Hurt, and then how many do I have there? Sid Holt was one that we hired that was back there. So there's a picture in E Times of the group that designed the microprocessor and the product. So
did they have an NMOS process when you joined?
No. So we had to bring up an NMOS process, which, going back to Motorola days, which was another reason why I left Motorola, is when you want to make a difference and somebody stands in your way for no apparent reason, you kind of say, what's going on here? It's confusing. So what happened was, because I had the process control model, monitor responsibility, I decided that I would have aligned with the same lattice structure and everything. If you know a little bit about the physics of the lattice, the mobility can change depending on which way it's oriented subtly. And so I had depletion load process and enhancement load process on the same process control monitor. So all you had to do is use the depletion mask so that you could implant for the depletion thresholds for the load devices. It was much faster process, much easier process, less transistors. It was the way to go. Well, Chuck saw what I was doing, so when we went to MOS Technology, we specified what we wanted. It's what I wanted at Motorola, which Motorola didn't want to do.
How many masks was that process?
Oh, it wasn't very many, 7 or 8, something like that. It wasn't very many.
And what was the wafer size at that point?
Well, the first wafers that I worked on at Motorola, they were like 2.5-inch wafers, but I think we probably were 3. I don't know if they had 3.5, but I don't think they were 4-inch wafers. But what Ed Armstrong, the process guy that was the head of process at Motorola for the NMOS process at Motorola, he grew a long beard waiting for 10 good die per wafer. And we were getting like 100 good die per wafer on the 6502. We had at least 10 times the yield per wafer. So we had, and it was because of their spot knocking. And
what is that spot knocking?
Well, when you build a mask, you have flaws sometimes in the material that's used.
Now, are these contact masks at this point?
Well, no, that's another thing. The contact masks mean that you would wear out your mask after used a few times. So these were projection,
okay,
or proximity.
Mm-hmm.
So it was proximity, if I got it right. And so that means it didn't touch the wafer. So if you got a good mask, you had a good mask that you could use for hundreds of wafers as long as you didn't damage them. So the spot knocking meant that if you compared two, you're not going to have a hole in the same place on both masks. So then if you went in and put a little ink or something that covered the hole up, you could create a perfect mask. That's what we had.
So you retouched the masks?
Yeah, yeah. Motorola wasn't doing that. So we had advantages in the manufacturing. So when we sold a $20 6501 and a $25 6502, we were making money.
So your team went to MOS to build a microprocessor. Who came up with the architecture of the processor?
Well, it would be Chuck, I would say. I'm a semiconductor engineer, so I'm building what Chuck once built. When I did step in and started defining things is when I realized there were some basic things here that could make a big difference. Motorola's 6800 had a clock generator that they sold for $69 on top of a $375 microprocessor. So if you add the two together, you got over $400. And so, but the
without any I/O even.
Right. So then the idea here is that if you design a clock generator and it's run on one wafer and the microprocessor's on a different wafer, then the characteristics between the clock generator wafer and the microprocessor wafer, one could be fast and one could be slow. So if you have a slow clock and a fast microprocessor, it could have some race conditions that would cause it to fail. So while Chuck's off on a marketing visit someplace, I'm talking to Rod and I say, hey Rod, why don't we just build a clock generator right into the 6501? Yeah, well, why do you want to do that? I said, because then you don't need a clock generator chip. Just put a resistor and a capacitor on it, or a crystal and a resistor on it, and you're good to go. You don't have to worry about it. And so Rod said, well, whatever. And so then Chuck comes back. I tell Chuck, hey, this isn't going to cost you anything. He says, well, as long as it doesn't cost anything and you can put it in there. I said, it's a metal option. If you want it, you have it. It's the same chip. 6501 and 6502 is exactly the same, except the metal layer. You just connect up the clock generator the way it's designed. So Rod has, and I have a bet, well, Rod doesn't think the clock generator is necessarily a good idea because it differentiates it from the pinout of the 6800. So you go, Rod says, we're going to sell a ton more 6501s than 6502s, so we make a little friendly bet while we're waiting for the die to come out.
And 6501 had the same pinout as the 6800.
Yes.
6502 is different.
Different. And
So
that's what
you made a bet as to the relative volume of the...
Yeah. I'm saying, I think technology wins over marketing. Rod says, marketing wins over technology. Okay. Well, when Motorola sued us, and then they required as part of the settlement to drop the 6501, I won the bet that day. Well, Rod was probably not happy with me. Whatever.
So
but
tell
Rod
us about...
and I were friends always.
Tell us about that suit. When did you hear about that? What was your thinking? What did you decide to do? How did you make the decisions?
Well, I never thought about being sued by anybody. But it doesn't mean that you don't get sued. But I didn't spend any time thinking about that. I figured we were doing something totally different. Motorola didn't want to do depletion load. Totally new process, totally new everything, totally new instruction set. None of the opcodes from the 6800 would run on the 6502 or 6501. And so therefore, what's their claim? Well, as it turns out, they were claiming patent infringement. Well, yeah, a 6520 chip is exactly the same as a 6820 chip. And you go, yeah, we violated your patent. Oh, okay. But then they said they tried to get us on trade secrets. Then one of the parties, one of the mask designers, brought the schematics. And you go, oh, that's not good. And then under deposition, and these are revealed. Well, this is not good. So, but we didn't need the schematics. It wasn't the same. There wasn't anything the same. All the circuits were different because the enhancement load process, all the critical performance was on bootstrap circuits to get the high drive for the power supply, and depletion load got those automatically because of the depletion loads. So we didn't have any reason to have a schematic, and so then this mask designer was, Chuck may have mentioned that in his interview, I don't know, but Chuck always had a problem with it. I won't mention who it was. So what happens is, when push got to shove, then the settlement was on patent violations, and the trade secret thing was given up. And so they defined the terms, and it was to drop the 6501. But the 6502 then was now the only one. So I wanted to bet technology won out over marketing.
So the 6502 onboard clock generator,
right.
Different pinout, different architecture, about more than an order of magnitude less expensive than the 6800.
Right.
How was that at that point going with your customer design-in process?
You know, I wasn't involved with that. Chuck was. So Chuck would make the customer visits, and then Will Mathis, there were 4 inventors listed for the one patent on the 6502. The one patent is on decimal correct. Motorola, the 6800, I don't think had decimal correct. That means that you set a bit in the status and the mode register, which is the P register. You set a bit to define whether it's binary math or binary coded decimal math. So that was a big deal for whatever reason. I needed to write a Fortran simulator of that to make sure that all the combinations were correct. So actually I did that design, but because we all worked on it, all 4 of us are on the patent. Chuck, myself, Rod, and Will Mathis. They're the 4 inventors. It's for binary coded decimal feature of the microprocessor. So, I don't know, did I answer your question?
Did folks, customers that use that BCD feature that you're aware of? maybe building calculators around the
Actually,
chip?
Atari used it
Mm-hmm.
because they used it in their Asteroids game. And I found this out because when I designed the CMOS version, I had to do it with one more cycle, so I didn't use my patent. That one more cycle made the Asteroids break up because they updated the score on the retrace, on the screen retrace. So because it took an extra cycle, it messed up their, the code was timed to the screen. So now, going back to it, the reason why MOS Technology basically couldn't make a go of it is because the microprocessor industry was very young. So where are you going to get the volume? And then with Centertech and Rockwell picking up the big orders in California, MOS is going out of business. That's what Jack Trammell saw. He saw blood in the water, and he bought up, I think, 6 months or a year's worth of calculators, thinking they're going to staff up. They were maybe 200 employees, and then what happened was, Jack said, I don't need any more calculators, chips. Well, they're gasping because the microprocessor industry didn't build at the speed at which Chuck told them it would, or indicated. And so that's when Jack came along and acquired MOS Technology, and that, I was gone by then.
So the revenue growth didn't happen fast enough to keep MOS Technology in business. Jack came in and acquired it. And when did you leave?
I left in about March of 1977. And so the microprocessor came out in the summer of 1975. We left and dropped the payroll. We were dropped from the payroll of Motorola on the 19th of August. We were picked up on the payroll of MOS Technology the 19th of August, 1974. So within a year, we brought up a process, a new processor, and marketing was started. In September of that 75 is when we had a wonderful reception at the Moscone Center.
Mm-hmm. I remember that.
I remember that? That was the awesome party. There were so many people wanted a chip. So many people. I remember.
I could only afford the manuals, so.
Is that right?
I got the manuals, but not the chip.
Yeah, there was a mason jar, maybe about that tall, of chips in it. Chuck, this is Chuck. This is classic Chuck. Chuck is the showman. And so, and Rod and I were there, and so we had a lot of beers. It was in the St. Francis Hotel, and we had beers and talked with people, and a lot of people interested in what we created.
So before you left MOS,
Yeah.
who had designed the 6502 in to systems?
Well, I really don't know. I know apparently Wozniak bought one of the chips.
Mm-hmm.
Various people bought the chips. I would work the floor, and you would take one of their cards that they gave you, you swipe it and give them a data sheet, and this is what we did for hours at a time. You could look down from the second floor and look down. Here are all these people around our little booth knocking over a pinball, not a pinball, what do you call it, a pachinko machine or something like that with little balls, and our neighbors were not happy with us because they were getting trampled trying to get a data sheet. So, you know, it was just the funnest time an engineer could possibly have.
Were people skeptical that you could build and ship a microprocessor at a tenth or less than a tenth the price than Motorola? Did you have a lot of people questioning you about that?
Well, see, again, I'm a design engineer at the time, so I don't see what's going on in the market. Chuck sees what's going on in the market, and Chuck had his way that I think Chuck could cause some people to doubt because he tends to manipulate the information a little bit. Where I'd say, hey, this is the reason why we can do what we're doing. The process yields 10 times as much, and we got the same size wafers, And here's what the cost could be, and here's what we're selling for. We're making money. And so if you have any question about it, hey, we'll be happy to show you the schematics or anything you need to see that we know what we're doing. We know what we're doing. They're very successful at building bigger chips in the calculator market. They were selling bigger chips than we were doing in the calculator business at a lower price. So all the experience is there. We know what we're doing. The guy that's running the operations is a guy from TI. TI knows what they're doing. And we have their best people. So if you had a question, now what Chuck actually told him, I don't know. But I wasn't in those meetings for the most part. I was back designing chips. I designed a VIA without any computer assistance. That VIA is why I knew I could start my own company. I would be making money off of just not even have to use a simulator. By this time, I knew the transistor sizing, see? I knew what it took. So I could design chips without a computer.
So how did the VIA differ from the PIA?
Well, what Chuck, I can still see the Arby's restaurant there in Norristown. And he comes back from one of his meetings and say, hey, we need a timer. We need a timer. Okay, we need a serial port. Okay, so what are you saying, Chuck? Well, let's go to lunch. So on a napkin, the old classic napkin, lunch napkin, you know, there I am saying, okay, you're going to have PIA plus a timer plus a serial port. Wow, that's more registers. Okay, so we're going to have to keep it to 16 registers, okay? Because I need 16, I can do that. And then, so that's Chuck and Will and I have lunch, and they say, the application guy, Chuck, okay. So then I go back to the MOS, and now I have to design it. So I designed it, and Chuck says, no, we have to have whatever, more compatibility. So then I had to redesign it. And so I designed it twice with a different pinout. I don't know what the first one was, but then I said, what about the serial port? He says, just any serial port. That serial port was used as the mouse interface on the original Macintosh. And so it's a weird serial port. It's 8 bits in, 8 bits out. It's synchronous, not asynchronous. If I had to do all over again, I said, Chuck, we need a UART plus a timer plus the I/O pins, and we got a really good product. But that serial port is being used in different interesting things, but it's kind of weird. It's nobody ever duplicated it, and I don't think anybody ever would. But it's a serial port.
Were you thinking at that point about applications for this chipset? Did you consider what it might be used for, what software might be needed to make it a unit for a future system?
Well, not really, because I kind of had my boundaries pretty fixed. Chuck, you're doing the marketing. That's your job. You tell us what we need, we'll make it happen. And Will, he was somebody Chuck found in the neighborhood, so to speak, that really knew applications very well. Will did the hardware manual. Chuck did the software manual. So that we had our focus. So that's how we thought we'd be successful. You focus on that, you focus on this. And so coming back to your questions, some of these questions I wasn't involved with. However, I did help get the Pong chip. I think the Pong chip was manufactured, part of the volume was manufactured by MOS Technology, or another Atari chip. So I actually worked through some of the details of getting that figured out. And so that and the VIC-20, I worked with the design engineers on the VIC-20. Now Chuck was completely opposed to what I think was the VIC-20 and the Commodore 64. He was PET. That's industrial strength stuff, if you know about the PET versus the Commodore 64. The PET had a Hewlett-Packard 485 bus on it, and this is industrial. This is real engineering. This is real computer. And then, of course, it had the chiclet keyboard, which was Jack's mistake, but Chuck had to put up with Jack. But anyhow, if it had a full-size keyboard, it would have done much better at the beginning. It got a bad image from the chiclet keyboard. So, but going back to the Commodore 64, from what I remember, the design engineer, Al Charpentier, and he was the guy that was behind some of the sprites and things you could do to make these video games and other things. So that wasn't my creation. That was these other guys. So I was more into just straight-laced I/O, processor, do what you can with it. But I did do something Chuck thought was impossible. I took that serial port and I drove the composite video on a TV and I made a barnstorming game out of it. I did it in 2 weeks. Chuck says, "You can't do that." I go, "Yeah, I can." I figured out the timing. I'd be running it at 4 megahertz. That's another part that the industry really doesn't really know about. We were running 2 to 4 times faster than Intel or Motorola. So not only were we a tenth of the cost, we were twice as fast. Anytime you're twice as fast, twice as low a cost, and we were lower power because of a depletion of the process. So we were lower power, higher speed, lower cost, and lower power. We had everything. Oh, it was easier to use if you know the coding of it. So we were easier to use, lower power, lower cost, and twice as fast. You got a winner. Any one of those things, you got a winner. All 4 of them, slam dunk.
So at that point, did you have in your mind or in your dreams what would ultimately turn into huge, huge volume for the 6502 architecture? Or?
I didn't know what the volumes would be. All I know is that when you design something that is so right, what is possible might happen. There were no bets. There were no, it's like DEC, I think, going MOS Technology, small company, even though it looks like it's PDP-11 in some ways, they have to go with Motorola. Oh, wait a minute, there's these guys that know how to do marketing, and they know how to manufacture these things. We're going to go with Intel. So you go, really? That architecture wins out over ours? It's not about whether the architecture is better. It's, do you know what you're doing in manufacturing? Will you support your customer's need, like you were saying about Bob Schreiner, and saying, what's going to make it work for you? Let me know what it takes. Put together a deal. And see, the MOS Technology guys didn't know how to do that, I don't think. So I wasn't in the middle of that. I wasn't capable of being in the middle of that. I was too much of a semiconductor engineer.
Did you have problems with the integrated clock generator on the 6502?
No, no. It worked the first time. I never changed it. No, that worked great. Now,
so that could be because of your analog experience. You were really aware of what it would take to make that work.
I was the clock generator guy at Motorola at the time. Now, since then, I'd probably changed some of my concepts, but I also redesigned a cardiac pacemaker oscillator that was 10 kilohertz, Staytech 10 kilohertz crystal. It wouldn't start up right. So then they wanted to change it to a 32 kilohertz oscillator while I'm at ICE. So I do that design. That's the only chip I ever designed in my life I never saw, and it's a pacemaker chip. They called me on a Saturday and said, "Bill, your oscillator works great." Well, wonderful. Am I going to see it? Well, no, it just works fine. I never saw it. That was the last I heard of them. I guess they had to recall pacemaker chips. That's pacemakers. That's painful, literally, to replace it with my oscillator. So I was an oscillator guy, but the truth be known that David Gray, that's here, he got my oscillators to work really good on my 134 and 265 chips recently, and he found an article, and I go, oh, wow. So I thought I knew what I was talking about before, but now I've been just reintroduced to the whole thing, and I realized there's some characteristics that I wasn't aware of that we put into our circuits. They work like a champ. So anyhow, so my designs were successful.
Did you, you mentioned that you'd left MOS at that point? What motivated you to do that?
I wanted to design microprocessors, and I wanted to design commercial products or industrial products. Game products. I didn't have a calculator at home. My son got his first game system from Nintendo. It was a Famicom, 16-bit, but it had Japanese captions and Japanese characters, and Ricoh, who supplied them their chips. Ricoh supplied the Nintendo. It's the only exclusive agreement I ever gave anyone, exclusively for Ricoh to supply Nintendo 816-based chips for their Super Nintendo. Well, my son got a Super Famicom. He was popular on the street because, what's that? So, anyhow, I'm digressing here. But
okay, so let's talk about your transition from MOS.
Okay. Well, when we saw the situation changing because of the business climate, they were looking like they were going to go out of business. And Chuck was moving from a microprocessor team leader to a systems person. So he aligned himself with California after in the process of the acquisition by Commodore. Now, the timing, I'm not sure what the timing looks like there, but I left soon after, or in the process of Commodore acquiring MOS Technology in a depressed situation or a fire sale.
So do you know what year this would be?
1977.
Okay.
So about the introduction, I think, of the Apple II and what was going on there. And so what happened was I wanted to work for a real company, not a game company. I'm not a game guy. I like the industrial, the high quality. I only want to design something that goes into high volume production, used by many. And so looking at feeding the game or calculator consumer products, that wasn't my cup of tea. That's not what I wanted to do. But then, you know, what are my options? So I ended up, I interviewed at Xerox. They were going to double my salary, go to El Segundo, and Bob Markle, if I got his name right, flew me out while I'm an employee at MOS, and he wants to double my salary. And I go, okay, so why would you do this? Because it's hard to find microprocessor designers, you're one, right? So what would I be doing here? Well, you'll be designing, we're a research lab. So you design something, then we transfer it into production, then they redesign it for their production manufacturing. Oh, Bob, I'm in the wrong place. My designs don't get redesigned. They go into volume production right away. Or why didn't I do it right in the first place? Tell me what, you know, I'm not a research guy. I'm somebody that wants to make things happen, and how I know I'm making them happen is they go into volume production. They're used by people. We don't throw away designs. We just do it right the first time. So Bob, it was nice meeting you. Thank you. I'm going back to Pennsylvania. I need to find out my other thing I want to do, and I don't know what that is. So that's when Glenn Madeline, ICE, he's in the seminar business. He's teaching integrated circuit design or integrated circuit usage, and he was the first, Glenn was the first design manager at Motorola in Phoenix. And so when these integrated circuits started happening, he said, you know, Motorola, you're going to need somebody teaching the world how to use, because integrated circuit is so much different than resistors and transistors. Now you have a new way of doing things, and in order to get this out into the market, you're going to need somebody to teach integrated circuit engineering. That's his name of his company. So he hires me, realizing he could use a microprocessor guy to teach the world microprocessors. So then he asked me to put together a seminar called Microprocessors for Management. So I put that together. He hired me straight across the board, no raise. I'm going to Arizona. It feels right to me. I have 2 children under the age of 4. Now I'm going back to Arizona. I'm not designing anymore. I'm talking about designs. And I get a migraine headache. I'm talking to 50 people. He charged a good price for attending the seminars. And I get a migraine headache, and it's like, I don't know if it was a 2-day thing, but within an hour of the first one, it's like, I got a migraine headache, and nobody can back me up. I got to do the whole thing.
Are you teaching people to design microprocessors or to design systems with microprocessors?
Actually, you know, I don't remember what I taught.
You remember the headache, though.
I remember the headache, but I remember it's microprocessors for management. And it's about these microprocessors are going to change the world. And so it's not about designing systems, it's about knowing what to do, because now microprocessors are replacing other forms of logic. And I didn't have it then, but it's embedding intelligence into products. So you need to be aware of what that would change. Now that's what I'd say today. It's not what I said then. And so it was one of those things where I was probably getting a migraine headache because it wasn't maybe that good, but it was the best I could do, knowing what I knew at the time. And then I would be the microprocessor guy in a week-long seminar. And so I don't know exactly how many different hours I taught, but I know that at the end of the review, they reviewed each of the consultants that were teaching, and then they fill out, you know, what's your grade? I was getting failing grades. It's like, this is so painful, Glenn. I don't know what I'm doing. And the other guys that were doing this, I didn't feel like they knew what they were doing, but they were getting the A's, and I was getting failing grades. If I got a C, that was really good for me. And so I'm thinking, Glenn, I don't understand. How can Howard do that and me? And he gets A's. He says, Bill, you haven't figured it out yet. We're in the entertainment business. I go, Glenn. He says, you're trying to give them too much information. I go, well, they're paying for it. Don't they get the best? Well, they're coming here to Arizona because it's cold wherever they were. And you want them to leave thinking that they know something, but you're giving them they can't digest what you're giving them. So it's painful for them. Oh, okay, well, that's a mismatch because I'm giving them the good information, but they can't use it. And so I don't know how to, so then I dumb down what I have to say, and then my grades go up, and I'm thinking, this doesn't feel right at all, so I can't do this. So that's when I asked Glenn, so what's it all about? That famous question that's been asked and probably never answered. But Glenn, at the coffee shop, at the coffee bar outside of his office, and my office was next door to his, Glenn, what's it all about? Glenn answered it. He said, for me, it's about doing what you want to do, living where you want to live, and you're comfortable. Whoa, thank you, Glenn. Went back into my office. I'm not doing what I want to do. I'm living where I want to live, but my son was just born on a credit card, so I'm not comfortable because you didn't have maternity benefits. So here I am, not comfortable with my debts, enjoying where I'm living, but not doing what I want to do. Denny McLean, I think, pitched 30 winning. He had a 30-win season, which hasn't been duplicated, I don't think. Maybe, but I don't know. And that's what I feel. I feel like I'm Denny McLean. I just pitched a no-hitter, wins 30 games, and I'm out of the business. I need to get back into business. So that's So my transition from MOS to consulting, that's when I got to reverse engineer all of the popular, valuable industrial microprocessors for $5,000 per processor, which means that I had to set up a little factory line, assembly line. So bipolar, I had a bipolar consultant that he could help me with the bipolar, and then I had to put it together in the registers and what was going on. And, you know, I did some, Shell Oil Company had the first patents on dynamic RAMs, and they were chasing down MOS Tech, so I had to reverse engineer MOS Tech and show them that Bob Probstein used the same circuits he had at Shell. He was a designer at Shell, went to MOS Tech, and I just said, well, he's balanced bit line, hey, he's got in the sense amp. So I had to do this kind of stuff because I knew what the transistors were doing. So I wanted to get back, and so I transitioned to ICE. A year later, I'm starting my own company because Jack Trammell wanted me to design CMOS calculator chips because they're lower power. And so there's Frontier or whatever it was, semiconductor, Southern California. Is it Frontier or Pioneer? I don't know, something like that. I think it was Frontier, like the airlines, I think. But I'm not sure. But anyhow, that was the CMOS manufacturing for Commodore for CMOS calculator chips. That's how I got started in my own business.
So that's Western Design Center. So
yeah.
Did that happen before you left ICE, or did you leave ICE and then start WDC?
Well, what happened was I was doing all this talking about design, and then I actually trained NCR engineers how to design microprocessors. They were using emitter, I don't know if it's injection logic or emitter coupled logic. It was bipolar, and that wasn't fun for me to teach somebody about designing microprocessors that I didn't think was a good idea. But I did what I needed to do. They had the process, and whatever. So NCR, and then I forget who else. But anyhow, it was just consulting. So answering questions or giving them my best. I gave them my best. But what happened was I went to Glenn and said, I want to build up a design capability here. To do that, I need a circuit simulator and a logic simulator. So we found a logic simulator, circuit simulator, that was out of Bomar. ICE had been part of Bomar, the calculator company. Mm-hmm. And so Frank Jenkins is the same guy that was at Motorola. He did the circuit simulator and logic simulator. I'm thinking, that's good stuff. That works. So I knew Frank. And so then, but Frank left Motorola selling logic simulators and circuit simulators back before Verilog. And so what happened was that was running on a accounting firm's Prime 300. Prime was virtual memory. And so it could handle any size. So logic circuit. And so because of the virtual memory. And then I got that to work, and then I wanted to sell logic simulators and circuit simulators through ICE. So I was building up the base for designing chips for ICE when Glenn says, you know, there's a problem with designing integrated circuits. They don't always work. But yeah, but if you know how to do them, they work. Yeah, but there's a risk involved there, and you can risk our goodwill, our relationship we have. So I can't really take that risk. And I'm thinking, oh my gosh. Well, how am I going to do this? And so then, out of the blue, Chuck calls me. Jack wants you to design calculator chips for him. Oh. Okay. Well, I need a customer. I'll go to Glenn. Go to Glenn. Hey, Glenn, I got a possibility of designing calculator chips for Commodore. Glenn says, no. Jack ripped me off. Jack owes me money. It's not good. I never want to do anything with Jack ever again. But this is an opportunity for me to design chips again. It ain't going to happen here. Okay, Glenn. So then I go back and thinking, is this a two-way street or a one-way street? Go back, say to Chuck, I wanted to design a calculator chips working here at ICE. What do you think? I got everything set up. I got circuit simulators, logic simulators. We can get mass design done and all that. Nope. Jack doesn't want to have anything to do with Glenn. Glenn's a good guy. What do you mean? Now, Glenn ripped him off. I'm thinking, how can you both rip each other off? So that's when I decide, well, I can't do it here. Start my own company. So that's when on Mother's Day weekend in 1978, I think Mother's Day was maybe the 13th of May that year. I don't know. But anyhow, I visited Jack and Chuck at a casino in Las Vegas. Jack's down $10,000 when I arrive. Then he turns around and winning $17,000. That's what I remember. He says, well, you brought me luck. Let's go talk. Go up to his room. Chuck's sitting here. Jack's sitting where you are. I'm sitting over here on a sofa. Jack says, so, what do you want to do, Bill? I said, well, I'd like to design integrated circuits for you. Okay. How are we going to do that? I'll give you a department within Commodore. I'll make you vice president of Commodore, a whole division. I'll pay you more than I pay Chuck. Chuck is like, what? Where's that coming from? So Chuck wasn't too happy with that statement from what I recall. I said, well, I thought about Jack. I want my own company. How will that work? I said, well, we'll have an agreement. I've been writing agreements with ICE. We'll write an agreement. We'll put milestones in it. I get paid, and I'll break even, and the design will work. And how you know it'll work is I get a royalty off of each chip. So I don't make anything if it doesn't go into volume production. I believe in what I do. I believe what I do will be produce volumes. That's where I'll make the profit. I'll break even, and that's how it works.
So the idea was he'd pay you enough so that you had your costs covered for the design, and all of the upside in future was on a royalty basis. Based on a percentage of what?
Okay, now we go back to what happened at MOS Technology and why was everybody not happy? Why did everybody leave? There was a learning opportunity. Chuck put together the deal. Guess what it is? A percentage of profits. Well, you get to looking at who's cooking what books. You go, when will there ever be profits here? Well, you know, it's how you do your accounting. What do you assign to this and that and the other thing? So there were some really unhappy folks. Now, Chuck and I, you know, we're friends. Now, Chuck's hard to live with sometimes. But it's that, whatever you call it, the synergy of two different styles. But, you know, would I call Chuck a friend? I would. But there's some say, really? I am. I'm a friend of Chuck's. But I understand Chuck in a way that very few people probably understand him. And so, but I know he's a winner. There's a winner there someplace. It's like that story about the pony and all the crap. There's got to be a pony around here with all this crap. And so I think Chuck can put together some interesting deals that only Chuck can put together. It's just like a Steve Jobs in a way. And so if you know him that way, life is exciting, so to speak. Opportunities. So
what was the deal that you negotiated with Jack?
Oh yeah, it's per unit.
Per unit.
Yeah, it's per unit. So you sell it, you get a percentage of the sale price. I don't care if you make a profit or not. That's your problem. But I'm getting a percentage of whatever you sell it for.
And was he going to use some of those chips for internal use as well?
Yeah, yeah.
And how did you get compensated for those?
Oh, he never manufactured anything I did, ever, which is interesting, right? What he did was when I duplicated the LC5K3 chip out of Toshiba. That was some interesting design. It was a serial processor. And it's hard to reverse engineer an LCD implanted resistors. You can't see them on the surface. So you go, how is that happening? And you have these nodes that aren't connected up to anything. Well, they've implanted resistors in there you couldn't see. So I had to figure that out. It makes you use your imagination more when you, wow, that doesn't make any sense. That doesn't make any. Then they also embed into it some circuits that are phantom circuits that would confuse somebody trying to reverse engineer it. So all these tricks these guys used, well, I got it to work. But guess what Jack wanted to do? He wanted to get the Japanese price, which was half of the American price. So he wasn't going to buy any chips. He wasn't going to build any of my chips. He wanted the chip to design so he could go back as a negotiating. Okay, well,
Did he have that idea from the very beginning?
I don't know. Jack was shrewd. He may not have. He may have. I don't know. But he was a gambler, right? He was a gambler. So if he's going to gamble, and he's saying, well, could we build this any less expensive than buying them from Toshiba? He's making the business decision. It wasn't about my design running in a factory. It was about, can he make more money off of getting a better price from Toshiba?
Okay, so we were talking about the Toshiba calculator chip
Right.
that you did for Jack,
Yeah.
and you mentioned that you did the design, but he didn't use
No.
your chip.
No, and actually, I designed a 4-bit microprocessor, parallel. Now, the Toshiba chip was serial. But in order to get that to work, a scientific calculator now we're going after the scientific business. The other one was 5-function. And that's a low end. Then we're going to go scientific. In order to do the scientific, I said we needed to do parallel, not serial. And so you think, could we do the 6502? The 6502 would not have been good because it's floating point. 64-bit. We have to do 64-bit math. But sometimes we might not do 64-bit. We might do 24-bit, like the mantissa and the exponent on a single precision, right? So I have to be able to change from 32-bit to 64-bit and or other, whatever the math we needed would work. So Chuck had a coding, the guy that programmed it. His name was Shiraz. And so Shiraz, I don't know if he was in India or he was in Northern California. So Shiraz and I worked up what we were going to do. I don't know how much Chuck was involved with it. He didn't seem to be involved with it. And I wanted Will to help me with this because, you know, I'm a semiconductor guy. I'm not a processor guy. Really, if you think about it, I had to add on the microprocessor functionality working with the market, like what we've talked about. So as it turns out, a 4-bit RISC processor, it had like 16 instructions. But what I had was a field, a 4-bit field that would tell you how many nibbles. So if I wanted to do a 64-bit, I'd have a 16 4-bit nibbles. So it's a cool processor, and it also helped with the LCD interface. So I had the LCD interface also would be supported by this 4-bit RISC processor that could do 64, any 4, 8, 12, 16, all the way to 64-bit. I could do that, and so I had this new instruction set. And the 6502 wouldn't have been good at that and keep the size down. But then another thing that was the Achilles heel that I didn't know about at the time, because Sam Trammell, Jack's son in Japan, knew the characteristics of what was going on in the calculator industry, and 1 microamp of standby is a lot. So you couldn't even have 1 microamp standby. But I didn't know that. And I should have known that, but I didn't. And so what I designed into this is a single transistor dynamic RAM using what Probstein did, what I learned at ICE. So I had a single transistor, non-self-aligned metal gate dynamic RAM on the chip. So I could save space on it because everything else had static RAM. So here I am thinking the semiconductor technology that I knew, and I got it to work, and it works fine. Worked fine, but
too much power.
You had to refresh it. So I had to have a refresh cycle in there. So I had to refresh the memory, and that was over a microamp. So that wasn't a good design.
How did you get involved at the Western Design Center in the 65 CO2? How did that project start?
Okay, so Xerox, I have to say, the first customer after Commodore. Now, Commodore didn't want the CMOS 6502. The NMOS was low power enough for things like the PET and these other things. They weren't. It was already lower power than anything Intel or Motorola had. So they weren't interested in this CMOS version. So after Jack was fired, I thought he quit because he made $1 billion or something like that. Or Commodore sales was over $1 billion, which is a big deal for Commodore. But apparently Jack was kicked out by Irving Gould. And I didn't know that until the book was published about On the Edge, that book. You're familiar with that, right? So what happens is they pull up stakes. They brought a truck, you know, whatever, a truck by the office, took all of their equipment, and take off with all the equipment that they felt was theirs from an office that I had a $50,000 note due on in 6 months. I just purchased this thinking we're going to do well, and then they didn't want to do anymore. I didn't have any other customers. That's one thing Jack said, exclusive. You don't work for anybody else. You work for me, you don't work for anybody else. What I translated is I can't even talk to anybody else. Like sales, I can't set up a next opportunity. So when Jack pulled up with his truck, so to speak, it's the guy from California, the CMOS, the design manager there, he took everything he thought they owned and left that day. And so then what I'm doing is saying, oh wow, 3 kids under the age of 6, 1 customer, gone. Now what am I going to do? I call up Bob Marco at Xerox. Hey Bob, I'm available. So this must have been near Christmas. Can you come over?
And what year?
1980. He goes, can you come over? Yeah, I need to talk to you. Sure, I'll be over the next flight. So, you know, bank accounts probably on a credit card and all this other stuff. So then I go over and meet with Bob, and I said, so Bob, so what do you have in mind? He says, well, Bill, now that I have you, I couldn't hire you, and I took in their vice president of Commodore. Xerox is going to give them their most advanced process just to have a part of my time. And Bud Fry was their vice president at the time, who was managing me. We met at Xerox, and Bud Fry listened to him. No, we went 100% of Bill, sorry. So then when they pulled up stakes, then I go back to Bob. Now Bob's saying, come on over and let's talk. He said, what happened? I said, well, I don't have any business, you know, exclusive for Commodore. Commodore left. I don't have anything to do. Okay. Talks to his secretary. We had secretaries back then. Excuse me. She leaves, comes back with an envelope. Bob hands the envelope to me. I open it. $25,000 check. Bob, what's this about? He goes, you have a nice holiday. I said, but what are we going to do? We'll figure it out after the holiday. Yeah, but why would you just give me $25,000 without any contract or anything. He says, Bill, when a microprocessor design engineer becomes available, you lock him down. I want to talk to you after the holiday. We'll figure it out. Well, thank you, Bob. Came back. I want you to teach my guys how to design microprocessors. That's when I hired Diane and trained her in 5 weeks to help me make good on my my contract. So I taught her mass design. But anyhow, that whole process is so random that you go, how does that figure into anything? You go, well, it's the way it worked. It's the way it happened.
So how did you get from teaching Xerox to design microprocessors to restarting the 6502 legend?
Okay, so the 65CO2 came out of the fact that GTE, while I was at ICE, I gave a seminar on microprocessors for management.
So they were one of your students at ICE?
Not GTE, EM&M Semi, remember?
Okay.
You know, we were talking about that earlier. Well, EM&M Semi was there, and Fran Kirsch, who has no vowel in his last name, I think it's KRCH. Fran Kirsch was the marketing guy for EM&M Semi, and he, I guess, was convinced by Glenn that this would be a good investment on EM&M Semi to hear this seminar or whatever. I'm not exactly sure what happened there. But Fran knows me. Dr. Desmond Sheehan got his PhD from Stanford, got his undergraduate in Scotland, I think. He is the vice president of technology. He was the vice president of technology at the Lenkirk division up here. And he was the one that proposed semiconductor operation to GTE corporate. So he needs to make this work. And his career is attached now to getting technology into the factory because he's convinced corporate they need to be in the semiconductor business. And so Fran Kirsch is a marketing guy. And so Fran knows me, introduces me to Des. Des and I hit it off. Des says, I need to send you to the Atari division of GTE in Lenkirk. No, not Lenkirk, in outside of Antwerp, Belgium. So first international flight, I got to get this, and so I'm going over there, and they have a 6802 based key system for telephones. So they're telling me what they need for the 6802. 6802, serendipitously, Mitel had a unipolar dope polysilicon, which they were the first to do that. And it's oxide isolated, so it's lower capacitance. So I know that oxide isolated, unipolar dope, CMOS is winner. That's what we need. GTE figures this out on their own. But serendipitously, I have my secretary call the sales office for Mitel where GTE got their process. I didn't know they got that. So they got licensed on the 6802 and the process from Mitel. I have my secretary call the sales office in California. I get online with him. He says, "Can I meet? Can we meet in Chicago on Sunday?" This is a Friday. What? Yeah, I want to meet in Chicago or wherever it was, or Montreal or someplace.
That's where Mitel Semi was in Montreal, I think.
No, Ottawa. So we have to meet at this airport because you can't fly directly into Ottawa. And so it's like minus 30 degrees. It's 70 degrees in Arizona. It's in like, whatever, February. And so I go there, and they're saying, we fired our guys that were in Lake Tahoe designing the 6802, and it only runs at 250 kilohertz, and we need it to run, the original spec was 5 megahertz. I said, if it's so far off, I think I can get it to a megahertz or 2 megahertz, but not 5. I don't think I can do 5. It'll have to be totally redone, and I don't think you want me to do that, but I think I can get it to run at 1 to 2 megahertz, if that would work for you. Because that's what the original one worked at anyway. So you'd be matching up with the NMOS, but you're not doing everything you could have done had those guys knew what they were doing. Well, we fired them because they were apparently 2 forms of snow, and they were not really working too hard and enjoying themselves on the slopes and other ways. And so you go, how serendipitous is this? So I said, what, you know, basically I'll do this for $15,000. They give me a check just like Xerox did. Now I got the wolf away from my door for another whatever. And so another month maybe or 2. And so then now it's CMOS unipolar dope poly, good. Oxide isolated, wow, this will be good. I started my own process. I had my own rules called Oxy CMOS for oxide isolated CMOS. So I had my own design rules and everything. And so then Des sends me to Belgium. Okay, so I go to Belgium. Listen to these guys. 6802, they're using the NMOS version. And we want to add this and that, and the modem features and dialing features and all that. So I brought back the spec. That's what Des asked me to do. So then I put together 2 proposals. We could either do the 6802 version or the 6502 version. So Aldous Wilkins at GTE now running, he's the operation vice president, running GTE vice president, running their operation out of Motorola. He's got Motorola people all around him. And they're not happy with the 6502 because I left Motorola and the 6502 stole some of their thunder, right? So here they're all Motorola. And I got GTE vice president, Des, is there. We're having a meeting, Otis Wilkins, in his office. And I, at some point, so I presented 6802, 2-chip version, 6502, 1-chip version. So, presented that. Otis looks at Des and me, says, I'll be back in a little bit. So I thought he had to go to the bathroom. But what he did was talk to Fran Kirsch. And Fran Kirsch says to him, hey, it's been my experience that the smallest chip wins. Every time. He comes back, says to Des, it's your call, Des. You're the man. You make the choice. Des says, it's 6502 based. I got emotional, but I had to wait until I got in my car. Wow.
That surprised you?
It was the right decision. Sometimes in big corporations, the right decision isn't made. Des was the one. He knew technology, and when it was his turn, he picked the one that he believed in. I designed every chip that they had at GTE. All the chips that I designed, they were licensee. So that's how the 6502 came about. And then Rockwell licensed it like the same week or whatever. I always think GTE was first and Rockwell was second, but I think that's the way it was. But anyhow, the 65CO2 was it. Rockwell put in billions of modem chips because they used the CMOS 6502 in their modems that they were selling.
So how many 65XX, CXX instances do you think there are in the world?
Well, there have been estimates. Actual number, I've been saying 5 to 10 billion for the last 15 years. And we sell about 100 million a year. So, you know these little video games that you can get at Walmart for 15 bucks? They have my 816 of them. Those chips are sold for, I don't know, 25 cents. Full system on a chip, 25 cents. I mean, I don't know what the margins are, but they're very small.
Of course, Apple used the
Apple,
processor.
Yeah, Apple, they use it in the Apple IIc and the Apple IIe. But you know, if you add up all the Apple, you know, how many millions did they sell? 5 million? I don't know what the number is. 10 million maybe? Commodore sold maybe 50 million. But the 6502 used in floppy disk controllers and modems and game systems that you never heard of, they're billions.
So why do you think that is, Bill? What is it about the architecture that that has attracted so much usage?
Right. Well, I think we talked about this earlier. The architecture was never labeled properly, ever. So when you look at the architecture and you look at how it was used for Apple, Commodore, Atari, Nintendo, what you'll find is that the architecture provides for powerful solutions based upon addressing registers effectively. So we had 0 page as an example, 3 cycle accesses. And so we could actually access memory registers, addressable registers in memory to do floating point faster than you could do on an 6800 or anything out of Intel. I have this on my website, and I didn't do it. I didn't do the benchmarks, instruction level benchmark. GTE did it. And they come back when they did this, they go, Bill, did you know how awesome your microprocessor is in comparison to like the Z80 and the 6800 and the 8080? I go, really? Well, what that tells me is that they didn't do it as well as they could have, because I'm doing it as good as you can. So that means that they didn't. It's not like they could have, but why didn't they? I don't know. But addressable register architecture provides the resources to do anything with this little processor. That's why it was used effectively in these early systems. It just is 2 to 4 times better than the other guy. And did Wozniak know that? I don't know. He was maybe buying it for its price. But then that would mean that he fell into something that really was effective. But I'm saying when you do it the best you can do it, and nobody can do it better, you know that. But does the other person know that? No. They will use what the marketing guy's selling, and if it matches up, they have a match, they make money, that's the end of the day, or the end of the conversation. But for me, the architecture is the best it can at 8 bits, and the pipelining and what we did there was to minimize the number of transistors. So we did it the best possible. That's what we know.
When you, I think it could be said that you invented the idea of microprocessor IP as a business. Right. Did you have that idea and then pursue it, or did you find yourself doing it and then realized what you were doing? How did that come about? Okay,
Glenn Madeline again. Glenn Madeline taught me that if in the consulting business you can get somebody to pay for a study, you get paid for it that way. Then you give a seminar on it. Then you sell the book. You can sell it 3 ways, and everybody's happy. There's nobody complaining about that. The original guy got what he wanted. The next guy get what they wanted. They all get what. So if you can sell it 3 times. So I'm thinking, hey, if I design a 65 CO2 and I license it 10 times, that is better than what Glenn was doing. But the idea, Glenn started in my head. So then I'm thinking, you know, a microprocessor can be used for so many different things. And really, applying the microprocessor to an application, application-specific requirement, is better left up to the guy that knows the market opportunity. So for me, licensing a microprocessor fulfilled Glenn's business concepts, and I could design just the building blocks, and somebody else can enhance them for their market separation, their market needs. And so to me, so I've licensed it not 10 times, but over 60 times throughout the years. And so what was happening at the time that I licensed it was everybody was looking at, well, I have a factory that needs a second source. AMI was second source to Motorola at the time. So what people were trading designs so that their customer was supported if they went out of business. Now, companies like Intel might have, I don't know how many factories, 20 factories that could run the same design. So it's not the second sourcing anymore. So what I was doing is licensing for a fee. Then I could do what I wanted to do and actually collecting royalties. I get a quarterly fee, I get royalties, and I used to get sometimes the NRE for the startup of the whole thing. I still do that. But I'm very flexible. I meet the needs of my customer. So you need this, you need that. I'll mix and match to get the opportunity because it's getting to know one another and what's the right form of thing. So what I'm doing with Chuck right now is the right form of things, which could be the most lucrative thing I've ever done, working with Chuck again. But he has to make good on his marketing. so there you go. So I think it's the idea that I needed to change the equation. And for me, changing the equation is licensing for a fee at first, and then for a fee and royalties. And then just to prove that they had an accounting system early on, I have a quarterly fee. And it starts with a fee. And so now I have qualified that they know how to communicate financially, and now good luck with your market. So I cheer. I'm a cheerleader. So I cheer for people.
Do you have a favorite application of the CO2 that's come over the years?
I have favorites in various categories. How's that? Because I can't pick one. I just can't pick one. The defibrillator pacemaker one, I actually did all the life tests and everything and supplied defibrillator chips to a company. So I knew the testing cost was over $100 per unit just to test to make sure that they were, what they called infant deaths or whatever it's called, so that you don't want to embed a chip that's going to die in the first year, but if it passes that test, then from your own experience that'll last for a long time. And so I needed to go through all of that learning experience, but then I needed to find somebody that would manufacture life grade tests. And how that happened was Motorola got out of the business, Harris got out of the business, Intercell, if they were a combination, RCA, 1802, who would use an 1802 in a pacemaker? I don't know. But the company I licensed, ELA Medical, part of L'Oreal Pharmaceuticals, was the first to embed a microprocessor in the human body for life support. So these kind of people looked for me for 2 years because I had a clause in all of my agreements, still there, that you can't tell anybody about your license. So my licensees couldn't tell anybody where they got it. Wow, that sounds like negative marketing. Well, this medical company out of Australia said they looked for me for 2 years. Somebody must have not honored my agreement because they said, we went to GTE, they have the same instruction set. They went to Rockwell, they have the same instruction set, and they all said it's their microprocessor. But somebody, but I don't know who it was, told them who it was, me. So we're back to, why are you picking me? Because we can do business. The other guys are getting out of it for one reason, lawyers. So if they have a problem, they're going to sue you, and they don't want any part of that. I said, okay. Well, in my agreement, you're going to have to agree to indemnify me against everything. So, and we want to be real understanding that I'm giving you everything I know. So when the judge asks the question, what was your part in this? I'm saying I gave him everything I know. You got all the source, all the information. So I'm probably one of the few companies that are indemnified by my customers. So just, I needed to solve the problem. And the problem is that you cannot not use the world's best microprocessors to save lives.
So you've evolved the architecture over the years.
Somewhat.
Tell us about what changes you've made and why.
Well, listening to your customer is a good thing. GTE, the original packet switching, I think, for the DARPANET was out of a company called Telenet, packet switching. And so GTE, Des, sent me to Virginia and said, we need to see what they want in this microprocessor we're going to design. So they used the 6502. They said, there's no other microprocessor available that can outperform the 6502 for packet switching. If we could have memory lock, that would mean one processor working on a piece of information wouldn't be interfered with if it's doing a read, modify, write back into memory. So if you could hold off that, put memory block on there, and if you could do some bit manipulation, I forget what it was that they asked me. So there were just a few features that they asked me for, and I put them in. So those were why the enhancements. Then Rockwell wanted the bit manipulation instructions put in, which I put in, but it conflicts with my 816 opcodes. But they wanted to be able to set memory bit, reset memory bit, or clear memory bit, and branch on bit set and branch on bit clear, those four. So Rockwell wanted those, so I put those in. So I don't know, NCR is a licensee of mine, was a licensee of mine. And so I don't think they asked me for anything, but I listened to them, and that's where the enhancements come from.
How did you get to the 32-bit, 16-bit architecture first?
Well, nobody wanted it, but I wanted it. And I figured that if I could do the 16-bit and make it compatible completely with the 8-bit, I could get the 16-bit accepted. Excuse me. So what happened is I went to Apple, and Apple came to me. And they said, well, this is what we'd like. So they gave me these features that they'd like, but they said, we're not going to use it. So why are you telling me what you would like then? And I don't know factually if this is correct, but I was told that Wozniak came back to Apple to do the Apple IIX, it was called, then Apple IIGS, graphics and sound. And so so they gave me some features that they wanted for 16-bit, but they never said they wanted to make it compatible with the 8-bit, run the old code. But I figured, wait a minute, if you run the old code, and I had an 802, which was an 816 that was pin compatible, so you could plug it right into the old Apple II socket. Learned that from Motorola, right? Mm-hmm. So if you plug it into the old socket, hey, you got a customer. So mine was the first processor to emulate the previous generation. So I did that, but I remember visiting Apple for the last design review, and they said, Bill, you know we're not going to use it. We have our own 16-bit microprocessor. Really? What's that? 68,000. Okay. So you're not going to use it. Right. So I came back, addressed my team with tears in my eye. This is the right thing to do. Somebody will want it. So we finished it up. My sister actually did all the layout on the original design. I wanted a brother and sister to design the only 16-bit microprocessor in the world, and if it became popular, that would be an added bonus. That's what we did. So, because I designed it at home, so I'm a double entrepreneur. I've got my little company, but I need to do this because I know it's the right thing to do. I did it at home on a game table. Brought it in. My sister was the only layout designer because everybody else had to do the projects they were on. So it's got an interesting history. But in Newsweek, they called it there's a mythological figure that looks forward and backward at the same time. And the article, it's a short article, they had that, the 816 is that. So then they came back and actually Apple used it in the Apple IIgs. I went to Apple and Dan Hillman, is that Dan Hillman? I think he was the project leader on the printed circuit board design of the Apple IIgs. He invited me up. I said, what's going on? He said, oh, I just want you to come up. Came up to his office. He had the other designers of the Apple IIgs there. And I don't know if they gasped, but it seemed like they may have, because Dan hands me the first PCB that was fully stuffed. Says, Bill, I want you to hold this.
And that's when you found out about it?
That's when I found out.
That must have been very emotional.
Yeah, I'm an emotional guy. That was emotional. And then the other guys were like, how the hell does he get to hold it first? Dan's a good guy. And Wendell Sanders, another name, and he was one that visited me. Do you know Wendell?
I met him, I think, during the Apple III.
Yeah, he was the Apple III guy.
Yeah.
And Wendell's son was the head of the iPod division of Apple recently, and then he went on sabbatical. I don't know if he came back or not. But Wendell was the guy that came down and told me what, they might be interested in. And Wendell and I call us friends. I went to his big home that he was building up in the mountains, and I found out recently, about 2 years ago, we talked again because he wanted a white ceramic 6502 for his Apple I. He's got an Apple I. Did you know that? He's got a website of an Apple I. And he wanted something happened, and so we're trying to get him a white ceramic 6502. I have a couple of white ceramic. No, I think they're white ceramic. Maybe there was a purple one or whatever. 6501. People want 6501s. I've got 3 of them.
I only have plastic 6502s from that era.
Oh yeah,
You probably have a lot of those.
I don't know. I have a lot, but I have a few.
I think at Cinertech we didn't. I may be wrong, but I don't remember selling ceramic.
No, I think it came out of the original MOS because
because that's easy for prototyping. You can assemble it.
You take the lids off and probe them when you could. Now you can't, but yeah. But right. Also the plastic is lower cost, right? And that's what you were going for.
We were shipping
right.
in volume, and I don't think we had military customers or anybody who would be willing to pay the extra freight for a ceramic package. Well, you've, in addition to evolving the 6502 architecture and evolving the business model, creating this microprocessor IP business, you've also been pioneering at Western Design Center in other areas like education, for example.
Right.
Tell us about your vision there.
Well, on the way to education, can I make a...
You can make any numbers of detours that you want.
I want to make a detour to another important business model that I pioneered, the fabless semiconductor business model. I have a meeting. GT's in the meeting. They're a supplier, they're a licensee of my 816. Wozniak's in the meeting. A couple other guys from Apple are in the meeting. It's at Apple's headquarters, I think, if I recall. NCR is invited to the meeting. They're a licensee of my 65 CO2. Rockwell and NCR got together for a CMOS version of the 6500/1 one-chip microcomputer. NCR called it the Austin chip, code name. Bob Jones, NCR's there, out of Fort Collins. He knows what the meeting's about. Bob Jones is sitting right here. Des Sheehan's over here. This is who's in and who's out on supplying Apple with 816 chips. GTE, Daz says, GTE's in, we're licensed, we're ready to go. NCR? We're not in. What? Oh, I have to think on my feet. You need two sources, right? Okay. AMI, don't they build your custom chips? Centertic maybe? Whoever? Somebody? Yeah? I said, you control the quality of those custom chips you put in your systems, right? Yeah? Okay. I can retarget my design for that process so they can build, based upon your spec, your quality standards. The 816, I'll be the second source. GT is the first source. We don't need NCR. That was the birth of the fabless semiconductor model. And so then Sanyo, a licensee of mine, they are the best ever. Quality, great quality. They were supplying wafers, and I don't even think I had to pay for some of them because they were licensee. They wanted to see that it would run on their foundry. So they were testing, packaging, everything based upon being licensed. So I had a complete second source in Sanyo. I mean, a complete fabulous business model with them. And so when the Fabless Semiconductor Association was started, they wanted me to be on the board of the original charter board. And I said, thanks for the invitation, but I can't do it. The reason why is because I don't want Sanyo to even ever think I needed anybody else for my fabless model. So you figure it out, and I'll enjoy seeing your progress. So I wasn't on the board. I was a member for a while, and I still get their emails and stuff like that. But yeah, I started that, and that was in 1984, I think. About 10 years before the Fabless Semiconductor Association was started. Now, your question, education. So when you do these things, and you know you want more engineers to be creative, applying the sciences, practical application, engineering is the excuse me, engineering is the practical application of science and math. Electrical engineer is all about electronics. And as a semiconductor engineer, you want to know the physics of the semiconducting materials and how to take best advantage of, you know, electron movement in those semiconductor materials. And so knowing that, you'd say, well, wait a minute. If a learner, someone that wants to learn about these things, has the opportunity to use my technology in all of its forms. IP form, we have hardware description language, Verilog hardware description language versions of all of our chips. And then we have the chips themselves. And now we just introduced in October a board level product that would make it convenient for someone to get started with a USB port from your favorite PC, Macintosh, smartphone. I call them smart things. Something with a microprocessor I call a smart thing. So I don't want to keep repeating all the different things. So just a smart thing with a USB port you can power and use as a terminal for our small computers. So we have small computer boards. And we're looking for this maker revolution. I was in a presentation where Wozniak was the original maker. So, yeah, could I go along with that? Probably. But there are a lot of people that make their own things just because they wanted the joy of seeing something they did work. I may be one of those in a specific category called embedded intelligence technology. There's only one reason you design a microprocessor. And that one reason is to embed intelligence into things. The intelligence is completed when you hook onto it sensors and actuators that will do something with that intelligence And the software, the coding of what you want it to do, whoever is your coder, if that's yourself making something work, then that's the reason why you design microprocessors. Or we just have big boxes sitting on floors with air conditioning units and everything else. But the microprocessor is what changed everything for embedding intelligence into things. So I'm saying, in order to learn about this, just like Glenn Madeline found out that you need to teach about integrated circuits, I have started a foundation called the Bill and Diane Mensch Foundation to support learning about embedded intelligence. So now I want to say, think about it. We all have an embedded intelligence to do what we do as humans, and every living thing has an embedded intelligence. So just that message alone can help the learner figure out what do they want to learn about. You don't have a USB port. You don't have a port that downloads the information. Maybe someday you might, but right now you don't. And I think you would enjoy picking and choosing from this wonderful world of information that we have at our fingertips with the smart things we have right now. So to me, education is got to be the way of the future for humanity. And if we're in the information age, then I think that's to support the age of understanding. So I'm all about education. I've been supporting education financially for more than 25 years.
Do you see this becoming more and more of the future role of Western Design Center?
Well, yeah, I think it's pretty obvious that if we have a young engineer or a young learner, like in 5th grade, I'm going for the nursery. I want the mother of their baby to relate to the nursery rhyme called Old MacDonald Had a Farm. And I came up with this 4 years ago in April, 4.5 years ago, at an advisory meeting of Notre Dame at Stanford in Palo Alto. I couldn't sleep one night thinking about old man Stanford had a farm. And on that farm they built a university. And at that university they learned about embedded intelligence. And with that embedded intelligence they created exciting or engineering innovations with opportunity for all. E-I-E-I-O. So when the mother knows and the father knows their baby has a wonderful embedded intelligence, what will you do with that? But if they never related to it that way, then there may be a missed opportunity here and there. So that's how far back, that's how deep this interest runs. So I think that just knowing that when you program yourself with information and then what you're going to do with that, processing that information, then the first person that benefits is yourself. And when you get good at something, you'll have more left over for someone else.
So when you started this journey that's taken you here 40 years ago, something like that.
Right, 43 years ago.
Did you have any idea where we would be today?
No. I knew working on the microprocessor 6800 PIA, like I said before, I knew this was changing the equation. And I knew with the 6502 and what Chuck picking the instructions and what our goals were for it. You know, our goal was to be price competitive with the 4040 chipset. So I designed the 6530, which is a ROM. It had ROM, RAM, I/O, and timer on it. And so that was used in the KIM board. Keyboard input monitor. So the code of the 6530 had the key. It's really machine code monitor is what they say on Wikipedia. So it's a monitor that used the keyboard. So that's why so many people picked up, about 50,000 of them I think were sold, of the KIM 1. Very popular single board computer, probably the most popular. It's probably the most endeared single board computer of all time. Well, there was also a TIM, teletype input monitor, and that's what I used on the original tester for all of the microprocessors for the first 2.5 years, and I/O chips. I had little load boards and all this.
For testing.
Yeah, and a paper tape, and that's why I was talking to the guy that cranks the Babbage machine. He knows all about terminals, and so I want to get a terminal to hook up to my old tester that I have. But anyhow, the point is...
And we did a sim at Center Tech.
Yeah, you did a sim.
Manny Lemus.
Right. And so that was a two-chip system. It was a 6530 plus a 6502 was going to compete with the 4040. I don't know that we ever really competed with the 4040 or even tried to. I wasn't in the marketing. That was Chuck and his team. So to me, that was our goal. So we way overshot our goal. Way overshot it. So you asked a question, what did I know? I knew what we were doing was seminal. I knew Rod and I had the conversation at MOS Technology in their conference room on the second floor. Rod said, if this works as good as we think it's going to work, in his words, we can go to the happy hunting ground, as Indians saying, for heaven, knowing we did something very special with our lives. So that was Rod and me. We knew what we were doing. We didn't know specifics, but we knew what we were doing. And I, in that 1973 December when my first child was about to be born, is when I said to Chuck, we could build a home computer out of these chips. And so I knew we could do that. Now, the Apple II, Atari computer, and Commodore 64, VIC-20, all the Beeb out of UK. The Beeb is where ARM came from. So the designers of the original Acorn used the 6502. They're the only people that ever asked me about the abort feature on my 816 to this day. And
well, you'll have to tell us about that.
Pardon?
You'll have to tell us about. I'm asking you. So
what's that?
Tell us about the abort feature.
The abort feature. Well, Prime. I had a Prime 500, so I went from the 300 to the 500. That's a virtual memory, and what that means is that if you make a memory fetch and there's no physical memory there, then you have to abort that fetch and then repair the location. You could either move memory around in the system physically. It's really a memory management issue with the address bus, and then retry. So I figured, well, why don't I just build an abort? So if I go and something says I'm not there, then I don't want to change anything inside of the processor, and then I go off to an interrupt routine that says there's been an error detected, and then I repair the error, whatever that means, and then I retry. That's how I did it. So ARM put it into their processors. I've never chased them down because they didn't duplicate my 816. They used my idea, but I never pursued them. I talked to some lawyers in Philadelphia because I was an expert witness for Samsung, and they wanted to pursue ARM, and we had a conversation, but whatever. So this was a long time ago. But anyhow, you know, the idea of putting in some of these features and doing some of these things, it just felt right, and so I wanted to do it, and I did it. You know.
So what's next?
Well, these boards that we introduced to you at lunch are what I think, for me, is the most exciting thing I've ever worked on. And the reason why is next year, right now, I no longer have to say Apple, Atari, Commodore, Nintendo. We have our own boards now. So now we can work directly with kids, people that want to make a difference. But before, I would always indirectly feel good about the Apple II and how teachers would plug in boards into there. Professors would control things that they wanted total control. And when you're working with a PC, you've got an asynchronous bus, and you don't have the synchronicity that some people want. So now we have that. And we have the I/O to support sensing, processing, communicating as with the USB port on your smart thing, and then actuating, turning on lights, making motors move, and do things you want to do. So it's sensing, processing, communicating, and actuating. That's what we're about. We have an X for our accelerator. We call it XCELR 8R, accelerator. So our accelerator series has, that X has these letters in the corner of each of the X's. So we're doing little things because we're proud of what we're doing, and we're going to directly connect with people now. So then I won't be, yeah, the Apple was a great product. Jobs killed it because he wanted to make space for the Macintosh in education. That was a major disappointment for me. I've heard from the teachers and the professors that that was a loss for them. And the Commodore didn't replace it, and the Atari never really replaced it. So now we're doing it, but we're doing it with one small board at a time. But you're using your smart thing, so we're not trying to duplicate what the smart thing has. We're trying to add to the smart thing. So we want to work with all smart things, not just one or the other. So we don't need a high-resolution display. That already comes with your smart thing. We don't need to have HD audio or HD video or any of that. That comes with your smart thing. What your smart thing is, needs a way to interface to the real world other than the various wireless connectivity. And so we think we've got the right product at the right time. And we're happy to be there. And so we're not trying to outdo ARM at anything. We think of ARM as our prodigal son. Got to do what they got to do. And it's not something I want to do. But I'm proud of them. They started with my technology, and I wish them well. I buy their products that have ARMs in them. And, you know, it's what we're doing. So right now, what we're doing is the most exciting time in my career because we can connect with all levels of engineers. People that want to be engineers, people that are engineers, and, you know, our technology, because of our various boards we have, can service the kindergarten through postdoc, doing something with advanced technology using programmable logic devices. And then when they want to retarget to an ASIC, then they can retarget to an ASIC because of what we've done. So we open the doors to creativity you know, one opportunity at a time. But we embrace the category of microprocessors. So that means that we know what it is like to be a leader, and we also know what it's like to be a follower, although I'd say we probably aren't following anybody because we're doing it our way. And, you know, the things like Arduino and Raspberry Pi and, you know, Launchpad from TI and some of these other things, they're wonderful. They've got great features. They're very useful. They are used in education. We hope ours are too.
Do you see the maker movement you talked about, and we've talked about previously, as a follow-on to the beginnings of the computer, personal home computer wave that you started with the 6502? Do you see the wave that you started back in the day as really leading into this new world that we're seeing today?
I think so. Did I start it? I don't know if I go that far. I think the technology was available for people that saw that wanted to be part of that. That's why Wozniak is somebody that's referred to in this category, because he did something very visible, and out of that grew the world's most valuable company and the most valuable brand. It's no longer the most valuable capital market cap wise, but I think it's still the most valuable brand. So can things grow that way? Yeah. How many of them? I think we only got one of those, but one of them's better than none. But do I see the maker? I think what I'm amazed by is what people do with their creativity. I mean, right now, these smart things that we have, 16 gigabytes on a small, thin, it's like, really? You know, I can't wrap my head around that. And so that's an example of saying, did I ever think that? No. Larry, who is my mentor and someone that wrote the code for my terminal interface on my small computers, when I was designing 4 UARTs on my 265 chip, he says, 1 UART, 2 UARTs, maybe 3 UARTs, but why 4? Well, look at what we've got. And you go, well, I said to him, you want to interface to a PC, you want to interface to a printer, you want to interface to a modem, and you want to interface to a keyboard. Those are the reasons, and that's what I had him design into my Mensch computer. So to me, this maker thing, I'm a maker too, if you think of my Mensch computer, as I just wanted to have a reference design on how you could do some of these things. So we built that. I only built 100 of them, but this maker movement is very important, and I think it synergizes or energizes humanity in a way that's never been done before. And part of it, a big part of it, is the maker movement in coding these smart things. Doing things that you go, that plus this equals this. And that's what creativity is. And so opening up the doors to creativity is what we're doing our way, and it's simple elegance. You add to it. We're not successful until you're successful.
Bill, what would you like people to know about Bill Mensch or Western Design Center, and in particular, what is it that we might not know that this would be an opportunity to go on the record with?
Wow. Wow. I've tried to tell you everything in my answers. Well, one thing that has never been talked about. In 1984, Wall Street Journal, if you know the first page, there's 2 sections. There used to be 2 sections. They call it the first page. in the left-hand column was a technology article. I got a call one day at the Wall Street Journal. It said, I understand you're doing something with Apple or whatever. And I go, well, they use my microprocessors, but, you know, what are you talking about? And so I didn't know what he was interviewing me for. And so it was because they were introducing to the market the Apple IIc. It was time to the Apple IIc. I knew what the Apple IIc was. The Apple IIe then was retrofitted or whatever with the 65CO2 because Wozniak said it was 20% faster to do some of the things that they were doing in BASIC because of some of the improvements that I made. I didn't know if it was or it wasn't, but they must have benchmarked it or something. So it was a minor improvement. So what happened was the Wall Street Journal closed with a paragraph about me, quoting me, of saying Apple could build notebook-size computers using our CMOS technology we have in place today. They didn't do that. Nobody was talking about notebook computers back in 1984. They were talking about laptops. They were talking about big boxes, the Osborne or whatever you want to say. I'm saying, but I've said it would be a notebook for schools. That didn't happen. Now it happens. They're called Macintoshes. But at the time, you can see that power was a big deal, but performing and doing things that the kids could use in a notebook for education. So that's, I'm quoted in there. Well, rumor has it that Apple was unhappy with me because that first column was reserved for Apple. But Bill gets his last thing in. And so based upon that, there were professors at ASU and other people say, who's this guy in Mesa? Who's this guy that's getting this? And I couldn't believe how many more people read the Wall Street Journal. All of a sudden, I'm known. Prudential Beige calls me and says, we want to take you public. I go, really? Yeah, could you meet with us in Wall Street, at Gold Street, which is right off of Wall Street, I think. And so I met with them. And it was probably 84, 85, because of that article. And they want to take me public. And I'm going, I could still see the front of their building. And I go, you know, you really don't know what I'm doing. I don't think anybody knows what I'm doing, actually. But I certainly don't know what you're doing. And so we're like two ships passing in the night. So thanks for the invitation. Thanks for the opportunity to talk to you about this. But no, thank you. I'm happy doing what I'm doing. And I don't know what it would look like if we did what you're thinking, because it would change everything for me. I have it made. I'm doing exactly what I want to do. I didn't say, and I don't need your money. But basically, that's what I was saying. So when I see ARM do what they do, people would come up to me at conferences and said, they stole your ideas. I said, what? What are you talking about? Well, they're doing what you were doing. I go, yeah, but I gave them the ideas. I already knew I didn't want to do that. So I don't know what they're going to do with it, but that when I had at this conference, they had just gone public, and their market cap was $10 billion. Well, how do you feel about that? I go, I think that's wonderful. I mean, I don't want to do that. But the fact that they did it, and the fact that that may have made these smart things that we have in our pocket, the engine for these smart things, then you see the power of the business model. And so I couldn't be more happy about it. They did it, and I passed on it. I didn't want to do it. I don't need the money. I'm happy.
Bill, thank you very, very much.
You're welcome.
It's been a pleasure.
Mine too.